Okay, Bismillahirrahmanirrahim. Hi, we meet again. So this time I'm going to talk about isomer, which will be focused on the stereo isomers. Okay. Before this, I have discussed on the constitutional or structural isomer. And for today, we're going to discuss on stereoisomers. Okay, but before that, based on the modules, you can read that what is the definition of stereoisomers, or we can simplify it as isomerism. Stereoisomers are isomers that resulting from different arrangement of atom in space. Okay, so how the atoms are arranged in 3D. So for today, I'm going to cover on cis-trans isomer first. Okay, we're going to cover this part, and later I'm going to discuss on enantiomers, because under stereoisomer it can be divided into two, which are enantiomers and distereoisomers. So in distereoisomers we have cis-trans isomers, and the rest of this which is not in our syllabus. So we're going to focus on cis-trans isomers, okay, and enantiomers as well afterwards. Okay, so first I'm going to start with cis-trans isomers. But before that, you can read on your own the requirement for the cis-trans isomerism. Okay, there are two requirements for the cis-trans isomerism, and I'm sure you can read the requirement number 1 and requirement number 2 from the module. Okay, so basically cis-trans isomer will look like this. So now I'm straight away going to focus on the exercise part, how we're going to determine either the structure can form cis-trans isomer or not, and how to draw the cis-trans isomers. Okay, I'm going to discuss on exercise 1. The question asks for which of the following compound can exist as a pair of cis-trans isomers, and if it can exist as cis-trans isomers, you have to draw the cis-trans isomers. Alright, so first we're going to begin with structure A. So what you have to do when you are given this structure, you have to determine either this structure can form cis-trans isomers or not. So first what I'm going to do is I'm going to draw structure A, which I'm going to expand the structure. Okay, so we focus on C double bond C. For A, I'm going to draw the structure first, C double bond C, and the first carbon is bonded to hydrogen and bromine. The second carbon, it is bonded to hydrogen and chlorine. So when you read on the requirements of cis-trans isomerism, is it this structure can form cis-trans isomers? So let us check on the first carbon. The first carbon is bonded to two different groups. It's bonded to hydrogen and bromine. So carbon number 1 is approved. Carbon number 2 is bonded to hydrogen and chlorine. So it's also bonded to two different groups, which is also approved. So now we know that this structure of A can form cis-trans isomers. And how I'm going to write the structure of cis-trans isomers for structure A? Alright, so I'm going to draw the C double bond C first. Okay, let's say I'm going to draw the cis isomer first. So this will be my cis isomer since hydrogen and hydrogen is bonded at the same direction, or what is called, it is called as same side. Okay, it is bonded at the same side. Now I will label this structure as cis isomer. Okay, the next one, I'm going to draw the trans isomers for structure A. And the trans isomer, I'm going to do it like this. C bonded to C, but my H is at the opposite side. Oh, before that, this is the wrong one. It should be bonded to, this one should be bonded to, BR, should be bonded to BR, not CL. Okay, so it should be BR here. And for the second structure, BR and CL. So this structure is called trans isomer. Next, we move on to the structure B. Okay, structure B, I'm going to focus on C double bond C. Okay, so C double bond C, the first carbon is bonded to hydrogen and CH3. Okay, the second carbon is bonded to hydrogen and also hydrogen. So now we're going to check. Okay, the first carbon is approved since it is bonded to two different groups. This is called another group, and this is another group of atom. But as for carbon number 2, it is bonded to the same group or same atom. So means I can write for the second structure, cannot form cis trans isomer. Okay, so we move on to the structure C. Okay, structure C, still we focus or we highlight on the C double bond C. Okay, so this carbon, C double bond C, the first carbon is bonded to H and is bonded to this group of carbon, which is called as ethyl group, okay. So this one I'm going to write as CH2 CH3, and the second carbon is bonded to H and bonded to CH3. So we're going to check. This first carbon is bonded to H and bonded to CH2 and CH3. This will be considered as one group, and this will be considered as one group or one atom. So carbon number 1 is bonded to different group of atom. So carbon number 1 is approved. Carbon number 2 is also approved. So means structure C can form cis trans isomers. And now I'm going to draw its cis trans isomers. The first one I'm going to draw. Okay, so this should be cis isomer. Okay, even though CH2 and CH3 are different, I mean this group is not the same as this group, but still this compound can be said as cis isomer. Okay, since it has the same atom bonded at the same side. Okay, so this one I'm going to label as cis isomer, and the second structure I'm going to draw its trans isomers, which H is here and another H is here, and the ethyl group will be here, and the methyl group is here. So this one I label as trans. Okay, next we move on to the last structure, which is cyclo. So is it cycloalkane can form cis trans isomers? Okay, for structure D, basically this structure, carbon here is bonded to H and another bonding is Br. Another bond is here, should be H, and here should be Br. So if you read on the requirement for cis trans isomers, it can not only be occurs on double bond, but can also apply to cycloalkane. So in this case, structure D can form cis trans isomers, but how I'm going to draw the cis and trans isomers? Okay, so first, if you want to draw the cis isomers, you can draw it like this. Or just like this, H and Br, H and Br should bond it here, and this is the cis one, and the trans, you can predict how the trans structures should look like, right? So it should be Br here and Br here, H here and H here. So this is your trans isomer. Okay, so hopefully this video helps you to understand on cis trans isomers. Okay, you can try on the tutorial questions. Thank you.